Okay, besides finding zeros of a polynomial function, now we're going to add on a couple more key features. And one of the key features we're going to add on is to be able to describe the end behavior. So to describe the end behavior, basically what you're going to do is you're going to tell what is happening to the y numbers. So you're going to be looking at the left and the right side of the graph, and you're going to tell me, do the y numbers go up forever and ever, or do the y numbers go down forever and ever? If you say the y numbers are going up forever and ever, then you would say that they are approaching positive infinity. If you are saying the y numbers are going down forever and ever, then you're going to say they are approaching negative infinity. So you only have two answer choices for end behavior, and that is to either write a positive infinity or a negative infinity. Now there's two different ways you can do this. You can memorize this chart we have here, or you can type the polynomial function into the graphing calculator and look at the picture. If you wanted to look at the chart, then what you have to do is you have to look at the degree. And remember, the degree is the highest exponent. And you have to tell if the degree is even or odd. And then you also have to look at the leading coefficient. Okay, so let's say, for example, you had a problem that looked like this. So if I gave you x to the fourth plus x squared minus 10, on this one, the degree is 4, which 4 is an even number. So then I would be like, okay, so the degree is even. And then you would look at what's in front of x to the fourth. And in front of the x to the fourth, there is nothing. So that makes it a positive x to the fourth. So then I would say that it is a positive, because it's like a 1x to the fourth, and that's a positive. So then we would be looking at the first picture. So then I would say on the right side, the y numbers would be going up, so you would say they would go to positive infinity. On the left side, the y numbers should also be going up, so you would go to positive infinity. Now, if you had an equation that looked like this, let's say you had a negative 2x to the fifth plus x minus 10, then you would say, oh, okay, the degree is 5. 5 is odd. And in front of x to the fifth, we have a negative 2, so that is negative. So if you have odd negative, that would put you here in the last category. And then if you're on the right side, your y numbers would be going down, so you would say negative infinity. If you're on the left side, your y numbers would be going up, and you would say positive infinity. Now, what you would have to do is you would just have to memorize the chart, so that way you would be able to determine what way it was going. So if you would say even positive, you would put your hands both straight up in the air and say even positive is up, up. And then if it was odd positive, you would have to go down, up with your hands. And then even negative is down, down. And odd positive, it would be up, down. Okay. Now, we do have a special way that we would like you to write all of your answers. And so this next category right down here talks about how we're going to write the answers. Okay. So we're going to start out at, it says as x, and this little arrow right here stands for approaching. So as x approaches positive infinity. So basically I'm telling you if x is positive, then that means we're on the right side. So if you're saying x is positive, that means you're on the right side. And remember, f of x is just a fancy way of saying y. So then your job is to tell me what are the y numbers doing. And then we write as x approaches negative infinity. So if x numbers are negative, that means we're on the left side. And then you would tell me what the y numbers are doing. Okay. Now, like we said, if you don't want to memorize the chart, like we had up above, you could also just get end behavior by looking at pictures and determining what happens on the right and the left side. So on my first graph here, you'll notice that this top one is saying x is positive. So this is telling me here that we're looking at the right side. And if I'm looking at the right side, you're going to notice that this graph is going down. So if I put an arrow on it, it would be pointing downward. So if it's pointing downward, then I would say the y numbers are all going toward negatives. So I would write negative infinity. The middle one here says x is going towards negative infinity, which means that x numbers are negative, which is on the left side. And if you look on the left side, if I was to draw an arrow, I would be drawing an arrow at the top of the picture, which means all my y numbers are getting bigger. And if my y numbers are getting bigger, then it's going toward positive infinity. Remember, the answers for end behavior is either negative infinity or positive infinity. And then the other thing we're going to go back to, which we have talked about before, is y-intercept. And remember, the y-intercept is wherever the graph crosses the y-axis. And in our problem, it is crossing the y-axis right here. And that point will be written as 0, a number, and that will be written as 0, 2. Okay, so the y-intercept will always be an ordered pair, and it will be written as 0, and then wherever it crosses the y-axis. Okay, on the second one, okay, once again, x is positive, so that means right side. And if you look at the graph on the right side, you're going to notice that the arrow is going up, so that is positive infinity. And then x is going toward negative infinity, so that means left side. And if I look at the left side, the arrow is also going up, so that's positive infinity. And then the y-intercept is always going to be 0, and then where it crosses the y-axis. And to me, that looks like about 7.5. So 0, 7.5. Okay, so now what we're going to do is we're going to join what we were doing in our last lesson, where we are finding the zeros and also putting the end behavior y-intercept. And then we are going to make a sketch of the picture as well. Okay, so let's go to our graphing calculator to type this in like we were doing before. So remember, go to your y equals key. If you have anything in your y equals key, then make sure you clear it out. Okay, and then I'm going to type this in. And when I'm typing this in, just remember, it's always good to know how many total zeros am I looking for. So our degree is 3, so we should have 3 total zeros. Oh, wait a minute. Okay, and then I notice that I can see where it crosses the x-axis 3 times. So that means that I will have 3 real zeros and there are no imaginary ones. So then I'm going to go to my table and I'm in luck. I can see the 3 zeros on my table. It looks like they are at -1, +2, and +4. So there are no multiplicities because I can see all of them from the table. Remember, there are no bounces. These all just cut straight through. So for my zeros, I had -1, +2, and 4. So I don't have to do synthetic division or quadratic formula because I was able to find all of them right there. So now let's go back to the picture. Okay. On the right side, do you notice that the graph is pointing up? So if the graph is pointing up, that means on the right side, the end behavior would be going to positive infinity. So here on the right side, I'm going to put positive infinity. And then if I look at the left side, I notice on the left side, the graph is pointing down. So that means it's going to negative infinity. So here I'm going to have negative infinity. Now the y-intercept, we have a couple different ways we can find the y-intercept. So let me go back and show you. Okay, so I can go back to the table and the y-intercept is going to be where it crosses the y-axis. So you're looking at 0 in the x column, because remember we said it was always going to be 0 comma a number, so it would be 0 comma 8. Okay. So you would have 0 comma 8. Or if you go back up here into your equation, you will notice if I plug zeros in for each one of my x's, because we know x is 0, then your y-intercept should just be your plane number. That's why it says right down here, plane number, which our plane number is 8. So it should be the very last number, the plane number in your equation, which is 8. So if you don't want to go to the t-table, then this plane number right here at the end is going to be your y-intercept. Okay, so now we're going to sketch the graph. And when you sketch the graph, you must label the zeros and the y-intercept. So then I'm just going to come over here and I'm going to put a x and y axis on. Now I don't have to put every little dash mark for everything. I'm just going to be like, well, one of my zeros is a -1. Then I'm going to have a +2 and a +4. But you notice I didn't put every single dash mark. I just put those on my x-axis. Then my y-intercept is +8, so I'm just going to come up here and put a mark for 8. I didn't put every single little dash mark. I'm just putting a mark up there at 8. In behavior, I know on the right side that it's going to end going up. On the left side, I know it's going to end going down. And then there were no multiplicities because I know that the highest, the degree was 3, and I found all 3 answers from the calculator. So now I'm just kind of matching what my calculator has. So I'm starting here, and I'm going to go up through the y-intercept, come back down, and go back up like this. And voila, I'm done. Now, before we go to the next example, I want to kind of add one in here, because we're just going to do one extra one here that I'm going to add in, and then we're going to stop for today, and then we'll pick up the notes the next time. Even though I'm going to continue on with the video, you would stop it after this next one, and then we'll do the rest the next day. So we're going to kind of add this one in. So we're going to add in example 2b. Okay, and let's say you had this one, x to the 4th minus 29x squared plus 100. Because now we're going to run into what happens is you might not be able to see your entire picture. Because if I went back to my graph in calculator here, you're going to notice when I typed in the polynomial, I got to see the entire picture from the first one. Wonderful. But when I get ready to go type this one in, and I clear it out, and I'm getting ready to type this in, we're going to run into a small issue. Because when I hit graph, you're going to notice, oh no, I don't see an entire picture. I see what looks like 4 random lines, and they're not connected. But a polynomial has to be one fluid graph. These should be connected somehow. My issue is I don't know if they're connected at the bottom. I don't know if they're connected at the top. But it shouldn't just be 4 random lines. So we need to go over, how do I change the viewing screen of the calculator so that I can see the entire picture of the graph? I need to be able to see the whole fluid graph. So this is what we have to do, okay? On the calculator, you need to go to the window key, which is right next to the y equals. And you're not going to change your x numbers. The only thing you're going to change is the y numbers. So right here, we're going to change the y min and max. Okay. And really, it's just a guessing game. There's not much I can tell you other than to guess and check, and then go back and guess and check. Now, the only hint I can give you is that if you know the y-intercept, then you can change one of them into being bigger than the y-intercept. So if I go back to my problem here that I made up, you will notice that the last number here was 100. So I know that the y-intercept is 0, 100. Oh, I ran out of room to write that. Let me erase that. So I know the y-intercept is 0, 100, and that's a positive 100. So when I go back to my calculator, I would go here to the y max. So I'm going to arrow down to the y max. And right here, I want to, instead of being a positive 10, I want to be larger than 100. So I'm going to go 150. Now, the y min, this one is purely a guessing game. I don't have any hints or tricks for you on that one. So we're just going to guess. And I'm just going to say negative. And then I usually just try to go by like hundreds, you know, like 100, 200, 300, something like that. So I'm just going to try negative 100. Okay, and then I'm just going to hit graph. And then I'm going to say, look, I almost have it. I can almost see it. I just need to go down a little bit farther. So I'm going to go back to window. And then I'm going to go to my y min. And I'm going to go down a little farther. So I'm going to change it to negative 200. And then I'm going to hit graph. And now you can notice that we can see all of the beautiful picture. We get to see the whole fluid graph, and now I could do my end behavior, and I could answer all of the above. So if I was doing this problem, I would say, oh, look, well, I noticed that the highest exponent was 4, so there's 4 zeros. And I noticed that each one of these just cuts through. So if I go to the table, it looks like we have at, and I'll just scroll, but I have one at 5, 2, -2, and -5. So I can come back up here and I could say our zeros are at -5, -2, 2, and 5. So once again, I didn't have to do any work for that. I already listed my zeros. Okay. In behavior on the right side. So as x goes to positive infinity, what does y do? And then as x goes to negative infinity, what does y do? Okay, and if we look back at our graph, you will notice that on the right side it's going up, and on the left side it's going up. So then I would say my end behavior is positive infinity, and then when I sketch my graph, I would have -5, -2, +2, +5, 100, and it's going to up on both sides. So up, up. It's really sketchy, but it kind of looks like a W, and you're done. Now, when you are done with this problem, and on your calculator, and let's say you want to go back to the normal window, okay, you go to the zoom button here in the middle, and number 6 where it says Z standard, okay, so if you just type 6, then that will put you back at the normal window. Okay, and anytime you want to go to the normal window, then you just do zoom 6. Okay, so zoom 6 puts you at the normal window, and I would suggest always going back to the normal window after you do a problem, and then that way you could change it if you need to for the next problem, or maybe you don't need to change it, so who knows. But I would pause the video for this day, and then if you're gone the next day, then you can just keep watching the video. But that's it for the day 1, and I'm just going to keep making the video for day 2. So for day 2, we would just go in and we would type this into our graphing calculator. So I'm going to go back to my graphing calculator. Y equals, clear that out, type this in. Oh, whoops. So negative x to the 5th power plus 4x to the 4th power plus 13x to the 3rd power minus 66x squared plus 48x plus 32. Okay, and then I'm going to hit graph. And once again, I'm going to look at this problem and think the degree is 5, so I should be looking for 5 zeros. So I notice it cuts through 1, 2, 3, 4, 5. So I've got 5 real zeros here. So I'm going to go to my table. And on my table, it looks like I have one at -4, +2, and +4. Okay, so I have answers at 4, positive 2, and positive 4. So then I'm going to have to go ahead and work on my synthetic division. Remember, it doesn't matter which 0 you start with, so I'm going to start with negative 4. List out your coefficients, so negative 1, 4, 13, negative 66, 48, and 32. Okay, hopefully everybody's got the hang of synthetic division. Drop the first term, and then multiply, add. So everybody go through and work on that. And then make sure you get a remainder of 0. And then I'm going to work on the next one from the calculator and do synthetic division again. And once again, make sure you get a remainder of 0. And then we're going to do synthetic division last time with our answer from the calculator. Oops. Sorry, didn't mean to adjust that. Okay, so we started with x to the 5th, x to the 4th, x to the 3rd, so then we have x to the 2nd plus x plus 1. So then I would use the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then I would type in the part that's under the square root into my calculator. So negative 2 plus or minus the square root of 8 all over negative 2. The square root of 8 is a decimal. It's not a perfect square, so I would do a factor tree. So 8 breaks down to 4 and 2. 4 breaks down to 2 and 2. So I have a pair of 2's and a single 2. And remember, the pair number will go on the outside of your root. And the single number will stay on the inside of your root. And then all of these outside numbers are divisible by 2. So then I would have negative 1 plus or minus 1 square root of 2 all over negative 1. And then negative over negative makes a positive. So you're really just looking at having, oh, sorry, my equal sign got messed up there. 1 plus or minus the square root of 2. So then over here I would have 1 plus or minus the square root of 2. So since I'm going to have to make a sketch on my calculator, I'm going to go back here to my calculator. So second mode for quit. I'm going to do 1 plus the square root of 2. And then I'm going to do 1 minus the square root of 2. So I can figure out what those are as decimals. So it looks like about 2.4 and negative 0.4. So I'm just going to kind of write that down here so I have that. So 2.4 and negative 0.4. Okay, so let's go back to the picture. Well, actually, we can do the y-intercept here. Y-intercept is the plane number, so that's the number at the end of the equation, which is 32. So 0, 32. So now if I go to my picture of the graph, I have a small problem. I can't see the entire picture, so I need to go to the window. Sorry if you hear my dog barking. So if you go to the window, we need to change the y numbers. And remember, my y-intercept was 32, so I would go larger than 32, so I'm going to go 50. And then this one, I'm just going to go like negative 100. Let's try that. Graph. Okay, not quite enough. I need to go down a little bit more. So window, I'm going to go down to negative 200. And I'm going to hit graph. Oh, still not enough. So let's try negative 300. Oh, still not enough. Okay. Window, I'm going to go negative 500. See what I talk about? It's just a guessing game. Oh, and now we can see the entire thing. So yay! So now we're going to be able to go ahead and do our id behavior. But the reason I want to kind of point something out from here is do not change your window and then do your zeros, because once you change your windows, to me, this kind of looks like it might be a multiplicity, but it really wasn't a multiplicity from the very beginning. So that's why I would always do my zeros first before I change my window, because when you zoom and change your window, it kind of distorts your zeros and makes your multiplicities look different than what they really are. So please make sure you always have it on the normal window screen when you do the zeros, and then you can zoom and change the windows for your in behavior. So on the right side it's going down, and on the left side it's going up. So on the right side it's going down, so that's negative infinity, and on the left side is going up, so that's positive infinity. So when I sketch the graph, I have to put in negative 4 and then negative 0.4, and then we're going to have 2, 2.4, 4, and then 32. And then we know on the left side it's going to go up, and we know on the right side it's going to go down, and then we're just going to sketch it from our calculator. Whoops, sorry. Oh, come on, calculator. So then we're going to make this. And then we're done. Okay, and then we have one more for today. Okay, so on this one we're going to go back to our calculator, and we're going to go type it in. But before I type it in, remember, I'm going to go ahead and put it back on the normal screen. So zoom 6 is normal, zoom 6, normal. Now y equals, and clear this out. And then type this one in. Oh, wait a minute. Whoops. Back up. Okay, so hopefully everybody's typing the next one in. Okay, graph. Remember, highest exponent is 4, so we're looking at 4 zeros. And when I look at this one, I notice it only touches the x-axis once. And when you look at this one, do you notice that it is a little U-shape? So do you remember our multiplicities? This one is a bounce. So that means this number counts twice. And I can only see 2. So that means if there's 4 total zeros, and I know that this one counts twice, and I can't see the other 2, that means the other 2 are imaginary. So if I go find this one is at +3, so I know +3 counts twice. So I'm going to come over here, and I'm going to write down 3 twice. So then I have to do my synthetic division with 3 2 times. So everybody work on that. So remember to, drop your term, multiply, add, etc. And make sure you get a remainder of 0. And then you're going to do it again with 3. And get a remainder of 0. And you started with x to the 4th, x to the 3rd, x to the 2nd. And remember we talked about if b was 0, we had that shortcut, so you could just solve this like a regular equation. Whoops. So I'm going to go -x² minus 4 equals 0. So then I'm going to add the 4 over. Then I'm going to divide by -1. And then I'm going to square root it. And then when I do the square root, I'm going to have plus or minus. And then the square root of 4 is 2. And because there's a negative under there, I have to have an I. So my missing ones are plus or minus 2i. My y-intercept is the plane number. So that's going to be 0, -36. So now if I go back to my calculator, go back to the graph. Okay. I'm going to go ahead and change my y-min past, let's see here, my y-intercept was -36, so let's make that -50. So then I'm going to go ahead and hit graph. Okay. All right, and then I notice on the right and the left side both that it's going down, so -infinity on both. So -infinity, -infinity. So then I'm going to make my rough sketch. So I have 3. Now, you can't put imaginary roots on the graph. So don't try to graph plus or minus 2i. You can't do that. So if you have any imaginary roots, you cannot put them on the graph. Can't do it, can't do it. Don't do that. So then here I have -36. And then you're just going to kind of make it look like the calculator where we know it's going down, down on both sides. And then this side we know it's going down and it makes a little funky thing over there. And then you're done.